Section 6.1 is on roots and radical expressions. First, let's take a look at a definition. The nth root. This says, if a to the n is equal to b, then a is an nth root of b, which we write as this right here. So the nth root of b is equal to a. Here's an example with numbers. If we say that 2 to the 5th power is 32, then 2 is the 5th root of 32, written as this, which we read as the 5th root of 32 is equal to 2. Recall from Algebra 1 that the number underneath the radical sign is called the radicand, and now that little small number inside the radical sign we're going to call the index. So for example, in the expression the 5th root of 32, 32 is the radicand and 5 is the index. Let's take a look at a few rules that apply when we're taking nth roots. If n is an odd number, if your index is odd, then b has one real nth root. So for example, the third root of 64, or we say the cube root of 64 is equal to 4, and the cube root of negative 64 is equal to negative 4. Remember, that means that 4 times 4 times 4 equals 64, and negative 4 times negative 4 times negative 4 equals negative 64. If n is an even number and b is positive, then it has two real nth roots, one which is positive, and we call that its principal root, and the negative, which is its opposite. So for example, the 4th root of 16 is 2, and the 4th root of 16 is also negative 2. And the next rule says that if n is even and b is negative, then it has no real nth roots. So for example, the 4th root of negative 16 is not a real number because there is no number that when you multiply it by itself 4 times equals negative 16. So let's take a look at a couple examples here. We need to find the real number roots of each of the following. Number 1 is the square root of the fraction 25 over 49. We're taking a square root, so it's going to be either the positive or the negative, and the square root of 25 is 5, and the square root of 49 is 7. So positive or negative 5/7. Number 2, the cube root of negative 25. There is a real solution to this, and that solution would be negative 5, because negative 5 times itself 3 times gives us negative 25. Number 3, the 4th root of negative 256. This is like our last rule up here that says n is even and b is a negative number, so this has no real roots. Okay. Now, here's a little complicated thing. When you take the nth root of an nth power, this applies that if you're taking the even root of an even power and the result is an odd power, you have to use absolute value bars. An example of that is the square root of 6 is equal to the absolute value of, the square root of x to the 6th is equal to the absolute value of x to the 3rd. Why is that true? Because we're looking for the principal or non-negative root. How do we know that we're looking for the principal root? That's because there's not a plus or minus in front of the radical sign. For example, if I were to say the square root of x squared is equal to x, this is true when x is positive, but it's false when x is negative. Let's look at an example of that. So if x is 2, the square root of 2 squared is the square root of 4, which is 2. But when x is equal to negative 2, the square root of the quantity negative 2 squared is not equal to negative 2, but the square root of negative 2 squared is equal to square root of 4, which is equal to 2. Here's how I remember it. I just remember even, odd. If we're taking an even root of an even power and we get an odd power as our answer, we have to use absolute value bars. And let's take a look at a couple examples here. It says simplify each radical expression. So we have the square root of 25 x to the 4th. I can think of this as the square root of 25, which is 5, and the square root of x to the 4th, which is x squared, and I need to evaluate it and see if I have to use absolute value bars. I'm taking an even root, because there would be put like a little 2 in there, an even root of an even power, but my answer is not an odd power, so I don't need to have bars. So my final answer is 5x squared. Number 2, the 4th root of x to the 12th, y to the 8th. So evaluate each one of those separately. The fourth root of x to the 12th is going to be x to the third, because x to the third times itself 3 times gives me x to the 12th. But I did take an even root of an even power, and I got an odd power as my answer, so I need bars on that. Now let's evaluate the fourth root of y to the 8th. That's going to be y squared, because y squared times itself 4 times gives me y to the 8th. And I was taking an even root of an even power, but I got an even power as my answer, so I don't have to have bars. So my final answer is the absolute value of x cubed times y squared. So in this lesson, we took a look at nth roots and some of the rules that apply for those, and in particular, the rule about using absolute value bars.